pile of coal, the sun's awesome energy, a cloud-patched sky, a pony grazing. They're all very different, but they all share one very important thing in common. They're all involved in one way or the other in the carbon cycle, one of nature's most important recycling processes. All life, be it animal, plant, fungi, or any other kind, depends on certain key chemicals for its very existence. Without these all-important chemicals, there can be no life, no living organisms of any kind. And here, in the form of coal, is one of the most important of these chemicals, carbon. Carbon is a must for all life. All living organisms, be they buttercups or birds, must have carbon to make the carbohydrates, fats, and proteins that are at the very heart of living. Carbon atoms are, for example, so vital to us humans that they make up more than 18% of our bodies. Obviously, then, if all living things must have carbon atoms to exist, it's life and death critical that nature doesn't run out of them. And that brings us to an interesting question. After all the hundreds of millions of years that living things of one kind or the other have inhabited the planet Earth and used the carbon around them in the process, how is it that there are any carbon atoms left today? How is it that living things did not use up the Earth's supply of carbon atoms long, long ago? The answer is recycling. Organisms can still get the carbon atoms they need because nature recycles them, using them over and over again. To see how, let's begin by looking at some typical green plants. All green plants, no matter what kind they are or where they grow, play a key role in recycling carbon atoms and making them available for use time and time again. Green plants do this while making the sugar they use as food. The process is called photosynthesis, and the raw materials they use are water and carbon dioxide, a carbon-containing gas that's part of the air around us. Using energy from the sun, green plants, or as they're often called, producers, combine carbon, oxygen, and hydrogen atoms during photosynthesis to make the sugar they need. Plants then either break down this sugar to release energy, or they change it into cellulose, starch, or other carbon-rich chemicals. But regardless of what they do with the sugar they produce during the process, photosynthesis, during which green plants of all kinds take in carbon atoms from the atmosphere, makes up 1/2 of the carbon cycle. And here we see a herd of wild ponies. They're involved in the other half of the carbon cycle. They, like so many different animals, feed on grass and other green plants. When the ponies, or other so-called consumers, eat green plants, the carbon atoms that are part of them pass into the ponies' digestive systems. Once there, some of the carbon-containing plant tissues are broken apart, releasing energy. Other carbon atoms from the plant material are changed into new chemicals that become part of the ponies' bodies and milk. At the same time, the ponies exhale carbon dioxide into the atmosphere, thus completing the carbon cycle. On one side of the cycle, green plants take in carbon atoms from the air and make them part of their tissues. And on the other, animals that eat those green plants return carbon atoms to the atmosphere when they exhale. So far today, we've discussed how the carbon cycle works with living plants and animals. In addition, it's important to understand that dead organisms, such as this decomposing log and rotting leaf litter, or this dead fish, also play an important part in the carbon cycle. When organisms die, they decompose or rot. This is largely brought about through the actions of bacteria and fungi, such as the one we see here helping to decompose this log. These and other so-called decomposers feed on dead organisms, using some of the carbon in the dead tissues to build their own bodies. Much of the remaining carbon in the dead organism is, however, returned to the atmosphere as the carbon dioxide that's a byproduct of the decomposer's own respiration. Green plants of all kinds can then use these newly freed carbon atoms during photosynthesis. So far today, we've talked about what's called the biological, or short, carbon cycle. As we've seen, it involves the relatively rapid recycling of carbon atoms back and forth between the atmosphere and living organisms. Nature is not, however, always so quick. Some carbon atoms do not recycle nearly so rapidly. Here, for example, along the banks of this Virginia River, we find a perfect illustration of such delayed recycling, of carbon atoms trapped out of circulation for millions of years. What today are riverbank cliffs were millions of years ago thick layers of mud at the bottom of a shallow sea that once covered this area. These cliffs are world famous for the fossils found in them. Fossils such as these clams that once flourished in the ancient sea's warm waters. When they were alive, the clams extracted carbon atoms from the carbon dioxide dissolved in the seawater around them, and combined it with other chemicals to form their shells and other tissues. Fossils and deposits of limestone and other carbon-rich rocks hold huge numbers of carbon atoms trapped and keep them from being recycled for millions of years. It's only when such material weathers and breaks down that these carbon atoms are freed and thus made available for use again. Fossils are, however, just one of the ways in which carbon can be trapped out of circulation. Gasoline, coal, heating oil, and other such fuels hold still other carbon atoms captive for millions of years. These fossil fuels were formed from the remains of organisms that lived millions of years ago, and the carbon atoms trapped within them will not be free to circulate through nature again until we burn them as fuel. When that happens, whenever anything burns, carbon atoms are released in the form of carbon dioxide. And that brings us to what many scientists feel is a pressing environmental problem: global warming. Ever since the industrial age began in the 1800s, we have burned increasing amounts of coal, oil, and other fossil fuels. Today, our factories and vehicles continue to pour huge amounts of carbon dioxide into the atmosphere. So much, in fact, that the world's green plants can't remove the surplus by photosynthesis. The ever-increasing amount of carbon dioxide that our vehicles and factories continue to discharge into the air around us has upset the natural carbon recycling mechanism we've talked about so far today, and substantially increased the amount of carbon dioxide in the atmosphere. Many scientists are worried by this. They fear that the increased amount of carbon dioxide will act as a blanket that will cause unnatural warming and other possibly disastrous related environmental changes. We still have much to learn about global warming and its impact on the environment. However, whatever we discover will not change the fact that the carbon cycle is and will remain the way in which carbon atoms, atoms upon which all life depends, are made available for use time and time again.